back with class 9, and here is a deflection example using superposition. Okay, so we have a scenario here where we put two loads onto this beam. It's a round cross-section beam. That's nice and convenient, right? Because it's round. Round is funny. We're using steel and we're using US units, and we found what I is going to be right here, right? So that's a straightforward type of deal. So what we want to try to do is find the displacement at C due to these two loads. All right, so let me try for that. There you go. From Shigley, we were going to have to find so we want to find the deformation here at C. So what we're really going to do is kind of have two things going at once. So here I'll try to show them individually right here. So we have this deflection right there, but we're going to find it right here at C, right there. So we're going to have that deflection, and we're going to find the deflection right here, right, due to C, right? So this was 180 pounds, but we're looking for a deflection at a different location. Right here we have the 450 pounds. We're going to get the deflection right where the load is, and that's going to give us the overall of the two things. Yeah, I don't know what it's actually going to look like, but something along those lines, right? So it has both the 180 pound and the 450 pound that's happening onto the thing. So what we need to use is, let's see, not this equation, because this is one where they're symmetric, right? So we actually need, where'd you go? I think I went past it. Sure. It's the one I showed previously. There you go. We're going to use this thing, not this one. This because this is down the center, right? We're going to use this one, but we're going to use it twice. So we're going to use this equation. No, we're going to use this equation right here for the 180, right? Because we're going to need to find it like over here. And then we're going to, then for the other one, we could use either equation actually, because they're both, these should be equal to each other at the location of where the force is. So let's try that out right here. So the deflection, let me write out the equation again. The deflection at C due to B, let's say, because that's the load at B right here. I will use, I'll call it y of C due to B. And I guess I'll write out the equation. That one, as written in the back of the book, was F times A, and you have to remember what A is. Right? A is the location from the left. It's good to look at this thing right here, remember. And A is the distance from the left over to this thing. And B is really just L minus A right there. Right? So hopefully we'll be able to remember that. Times X, which is going to be the location that we care about. And along here, X is the location where we're trying to find. So it's going to, X is going to be 6 feet. And that's going to be divided by 6 EIL. And times X squared plus B squared minus L squared. So if we're going to put this in here, the force that we're going to use is 180. The A should be 2 feet, because that's how far over we went. Well, no, we should be using inches. Excuse me. Let's use pounds and inches for this, because we're going to have E in terms of PSI, right? So we have 24, and then we're going to have, for X is, that's really going to be what did I do right here? Oh, I see what I did. I decided to write 24 inches. Here we go. 24 inches, 48 inches, and 3 feet was 36 inches, and the overall length of the thing, let's see, I put in there of 108. And so when I got to this X right there, that's going to be 24 plus 48. Right? What is 24 plus 48? I can't do that in my head. Duh, 72. All right. Is that correct? Yeah, 72. And I even wrote it up above here, so I did see it right there. And so now we're going to have divided by 6, 30 e to the 6, because it's steel. Right? I said that up here. And what else we have? I. So I wrote out what I was, 63.62. And L was 108. Right? And now I have x squared, which is now going to be the 72 squared, right? 72 squared, that's the location of the thing. I'm trying to double checking. Oh. I wrote out, this is the wrong equation. This was supposed to be, I see what I did wrong. My bad. This one was supposed to be L minus X. That's why I had that thing written down there. Shoot. There you go, yeah. That's this equation right there. I messed up. My eyes shifted up and I looked at the wrong one right there. But that is L minus X. Let's see if I do something else wrong. Yes, I did. Shoot. Should I re-record this? I guess I'll just look like a fool. That's fine. I don't care. 2LX. Yeah, that was right. Okay. So this should be L minus X. So that's 108 minus 72. Right, so X is 72. That's why I had that in there. I mistook why I had that written in there. I should think instead of just read. All right, so A is 24. And is that squared? Yep. Minus 2. L is 108. And X is 72. Is that right? Yeah, 72. And if we do this, we get, it comes out to a negative 1.231 e to the minus 3, and these are inches. Right? So that's the deflection right here. We could call this right here is going to be y at C due to B. And then this one right here that we're going to find is going to be the YC, whoops, meant to put it before the comma, YC because of C. And as I mentioned, we could use either equation because they should equal each other right here at this location, right? So this is for the deflection anywhere in between here. There's deflection anywhere between here, including at that spot. So, because we haven't used the first one yet, let's go ahead and write that out, right? So that's going to be YAB, I think. Yeah, YAB, and I should have just written this at the top like before. I didn't, but I didn't. So there you go. 6EI over L. And this is the one that's x squared plus b squared minus L squared right here. And so we have YC due to C is what we're going to find here using this equation. So now we have 450 because we're using this load at the same location as where the load is. I should also mention, maybe before we go any further, maybe before I go further, I should write what all these things are. 450 pounds. In this context right here, you got to remember what B is. B is the distance from the right-hand side to F. So B in this case is going to be 36 inches because this load is 36 over. So let's write that over here. B is 36 inches. What else? The location is still, X is still 72 inches. And the length is 108. Okay. That's a good thing to do to start with, just to double check that you're using it correctly. And so X is going to be 72 over 6, 30e to the 6. I, we found that before, right at the top, that was 63.62. And the last one was L, right there, or 108. And then the X squared is 72 squared plus B squared, which is 36, and minus 108 squared. And we should end up getting something along the lines of negative 4.889 E minus 3 inches. So this is significantly more than that, right? It's pretty much 4 times the amount. Well, it was a larger load, and it is at that location. So if we want to find the deflection of C, we add the deflection of C at B, the deflection at C because of B, plus the deflection at C because of C, and we get a negative 6.120 E minus 3 right there. So it's pretty small. But let me look at the, I do have, I plotted this out right here, right? So here are in Excel, obviously they're pretty small, but you could see here's the deflection right here in yellow due to B, right? This is the deflection at C due to B. Here's the deflection at C due to C, and then here they are together. All right, so I have a dynamics class to go to, so we will end this example right now.